We're looking specifically at parallel and perpendicular lines today. Something you might want to note at the top of the paper is the symbols for parallel and perpendicular. So parallel looks like that, just kind of like two L's slanted. And perpendicular, we'll see that a lot this year. That's like an upside down capital T. So remember those symbols, you'll see that a lot. What we're going to do is make a sketch for these different types of lines and then kind of talk about their slopes and give a definition. So parallel lines, we know what those look like, and we've been doing a lot with parallel lines this unit. So rough sketch, they look like this, and they're lines that don't intersect. If you remember about their slopes, and we're talking a lot about algebra with parallel lines today, so the slopes of parallel lines are exactly the same. Okay, then we've got perpendicular lines, so again, we're just doing a rough sketch. If you remember these types of lines from algebra, and honestly today is all review from algebra again, just like last week was, the end of last week when we did lines in the coordinate plane. If you remember perpendicular lines, they're lines that meet at a right angle, or 90 degrees. So I could mark that on the picture. Those lines meet at a right angle. Now, if you remember this from algebra, their slopes are no longer the same. They're what we call opposite reciprocals. And I'll give you an example of opposite reciprocals. So let's say that one of the lines had a slope of 3/4. The other one, opposite means you change the sign. So if this one's positive, the other one would have a negative slope. And reciprocal means you flip it upside down. So it'd be 4/3. This would be an example of opposite reciprocal slopes. We did a little bit last week with horizontal and vertical lines, so you'll still need to know those. Those will still come up. So horizontal lines look like that, and vertical lines go the other way. Okay. Remember that we also talked about last week, horizontal lines, they're kind of like the opposite of the axis. So like the x-axis is a horizontal line, it's the opposite. So these lines are like y equals some number. Like this would be the line 1, 2, 3, 4, y equals 4. Vertical lines are, they go the same way as the y-axis. So the opposite of that, they're like x equals some number. And this would be the line 1, 2, 3, x equals -3. You'll need to know the slopes of these lines. So there's a little trick to remember if you've seen it before. A horizontal line has a slope of 0. And you can make like a big Z out of the horizontal line. So it's kind of like a good little trick to remember that they have 0 slopes. A vertical line has what's called an undefined slope. So it's straight up and down. There is no rise over run. So you can make like a U. So that's kind of one way to remember to keep it all straight. Undefined slope. Keep in mind that if you had 2 horizontal lines, like if I added another one, 2 horizontal lines are always parallel. Or 2 vertical lines are always parallel. And also maybe know that if you have a horizontal and a vertical line, those are always perpendicular. So if I have one that's vertical, one that's horizontal, those always make a right angle together. Okay, so that's kind of the basics, and on the back is like putting it all into play. So a big part of this stuff is me giving you 2 lines or information about 2 lines and you having to tell whether they're parallel, perpendicular, or neither. If you're doing problems like this, all you are concerned about is the slopes. Okay, so if they ever ask you parallel, perpendicular, neither, all you care about is the slopes. So if I look at example A here, I need to find the slope of this first line and the slope of this second line. They're just giving me points on the line. Now, to find the slope between 2 points, remember you got to use that formula we looked at last week. y2 minus y1 over x2 minus x1. So I need to do that twice. So for JK, I'm going to label the ordered pairs. x1, y1, ooh, that's an x, sorry. x2, y2. Okay, so the slope of this line, let's see, I would do 1 minus negative 5 over 5 minus negative 4. And that would give me, that'd be addition on the top and on the bottom, double negatives. So that would give me 6 over 9, which I know can reduce to 2 over 3. If I go over here and do the same thing for line LM, so I'm going to label x1, y1, x2, y2. On the top, I would do 3 minus 0. On the bottom, I would do 4 minus 6. And I would get 3 over negative 2, which is reduced. Once you have the slopes, you just kind of take a step back and compare them. And you're looking to see if they have the same slope, parallel, opposite reciprocal slopes, perpendicular, or if they're neither of those. And these two, these are opposites. This one's positive, this one's negative, and they're flipped. Okay, so these are perpendicular lines. For the next one, now don't just go off of looks. These look parallel, but I need to find the slopes to make sure. If they give you the picture, all you have to do is count the rise over run on the graph. So like I'm going to count it for JK. I would go down 2, and if you go down, it's a negative direction, so negative 2. And I run, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I run 12. So JK has a slope of negative 2 over 12. You should always reduce your slopes, and that's negative 1 over 6. Line LM, that one you go down, let's see, 1, 2. So down 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one has a slope of negative 2 over 10, which reduces to negative 1/5. Now, these are not opposite reciprocals, not even close. They're really close to being the same, but they're not. So these lines are neither parallel or perpendicular. So, like I said, don't judge off looks. You'll get tricked because that one looks parallel, but it's actually not. So be real careful. Sometimes they might give you the equation of the line and ask you parallel or perpendicular or neither. You're still concerned about finding the slopes though. These two lines, they gave to me in standard form. You cannot look at standard form and say the slope. You need to change it to mx plus b. If I have a line that's in y equals mx plus b, I can look at that and say what m is, what the slope is. So you need to move both of these, which is kind of annoying, I know. So for JK, I'm just going to copy it there. I need to get y by itself. So I'm going to subtract 1/2 x over. And that gives me 2y equals negative 1/2 x minus 2. And then I'm going to divide by 2. And so I have the equation negative 1/4 x minus 1. Okay, the slope is what sits in front of the x. So on this first line, JK, the slope is negative 1/4. Okay, now I'm going to move LM into slope-intercept. So I'm going to subtract the 2x. And that's negative 2x plus 8. I'm going to divide by 8. And I have y equals, that's negative 2 over 8, which I'm going to reduce. That's negative 1/4 x plus 1. So the slope of LM is negative 1/4. And if I look here, they have the same slopes. So these are parallel lines. Okay. The last example, and this is kind of one where people, whoa, we zoomed in. There we go. This is kind of a problem where people kind of forget just exactly the process to go through, so pay close attention here. They ask you to write an equation for the line that's parallel to AB and that goes through point C. So I have a point. If I see parallel, perpendicular, whatever, I'm thinking slopes. So I need to use line AB to tell me my slope. And just like the last one, it's in standard, which I can't tell the slope from. So I need to change this to mx plus b. So I'm going to solve for y by subtracting 3x. So that's negative 2y equals negative 3x plus 12. And then I'm going to divide by 2. And I get negative 3/2 x plus 6. Okay, so the slope of this line is negative 3/2. My line is parallel to this line, so I want to use the same slope as this line, so I'm going to use negative 3/2. Okay, realize that you don't use that for anything else. Once you've found the slope, you're done. All I care about is the point and the slope. And I'm going to use this information and plug it into point slope. So I'm going to do y minus negative 2 equals my slope, negative 3/2, x minus 6. Okay, I'm going to distribute. And I've got, let's see, that's just y plus 2 equals negative 3/2 x. Negative times a negative is a positive, and that would be 18 over 2, which is just 9. Okay, last step would be to subtract 2, and my final answer is y equals negative 3/2 x plus 7.